all that good stuff. It's all in there. It works just like printf. Okay, so there are two important keywords in Objective-C, self and super. So if you're a Java person, you should sound similar, except you have this instead. Self is a reference to the current object. So if you're in a class method, self doesn't make sense. But if you're in an instance method, then self is a reference to myself. So if you ever want to call another one of your own methods, you can message self, and that will call that method on yourself. Super allows access to the superclasses method. Generally, I'm pretty sure all that super allows you to pass in is the same method that you're inside, I believe. Usually it's, the main reason it's super is useful if your superclass defines a method that you like, but you want to just add a couple of things to it. You can just call your superclasses method first and then do your custom stuff. Which I think I'll talk about a little bit of an example of that, defining initializers. Hey! I remembered my slides. Okay, so how do you make objects when you actually want to write code? In Objective-C, it's a two-phase process. The first thing you have to do is you have to allocate space on the heap for your object. So you call the method alloc, which is a class method defined on NS object, which basically reserves space in memory for your object. It reserves all the space it needs. And then that will give you a pointer to the memory address where the object lives, which you can then call init and its many variants to actually initialize your object and get stuff inside of your object. If you skip one or both of these, your object will not be properly initialized and will probably crash.
So that's equivalent to the C++ constructor.
And it's similar to the Java concept of new. New just does it in two phases, or actually, in some sense, new creates the space, and then the actual call actually is the initializer. So the mapping there is about the same. Does this make sense? Yeah.
For an object with a bunch of variables, does it allocate space for those immediately, or?
Yes, it will basically, like I said, Objective-C objects are structs, so it will just make enough room for the struct, which means enough room for all of its instance variables. Any other questions? Okay, so let's see how we define an initializer, and it may look a little bit weird to you at first. So this is a very, very common pattern. In fact, Objective-C Xcode usually provides a skeleton function for you for every object you make. The first thing you do when you want to initialize yourself is you want to call your parent's initializer to do whatever setup it needs to do, because you don't want to concern yourself with actually making the memory and all that stuff. You just want to let it do any of its setup if it has any. Assign that to yourself. And then there's this kind of weird thing where you check if self. The reason for that, and this is slightly less important these days because I think this is becoming out of favor, but in very rare cases, the initializer will return nothing. So you don't want to actually try to initialize yourself if the initialization failed. So you want to put this if check to make sure that the initialization actually succeeded. It very, 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 very rarely happens, but you should have it in case it does. And then when you're done, you return self. Notice here that if the initialization fails, it just returns the failed object, so it doesn't actually try to do anything else with it.
Question?
Do you mean that happens because the compiler makes an error, or because the superclass doesn't have some?
I mean, in general, I think the only case is, if there's some problem with it, I can't. Apple has an explanation of when it happens. I can't remember off the top of my head.
Apple's got an explanation in the documentation about when it could possibly happen in Cocoa in a lot of the frameworks. But if you've written your own class, even if it's subclass of an NS object, and then you've subclassed that and then subclass that, if somewhere in the chain you make a mistake or you want to actually throw an error, you know how unwieldy it can be to handle, to do try and catch around, inside of constructors and things inside of C++. This is a little bit more graceful way to handle bad objects that may be initialized incorrectly or that you want to bail on early.
Yeah, that's I think the main reason it's useful is that if in writing your initializer you discover that there's a case where you don't want to actually be initialized because there's some problem with the data you're given, and you just want to say, oh shoot, my initialization failed, you can just signal that there's a failure, and I'll show you. And there's an object, there's an object, I'll say, called nil, that we'll talk about in a couple slides, that you can say that you assign yourself nil, and that will indicate that I failed initialization. But does this format make sense? You initialize your parent, you initialize yourself as your parent first, then do your custom initialization, presuming that that actually succeeded. So this is a very clear way to do this. You can also combine them all into one line. Notice that there's only one equal sign here, because this actually is an assignment. The double parens are just to make it more clear that I'm testing whether the assignment succeeded. Because C, if an assignment succeeds, it will sort of return the value that was assigned, so you can check that that value actually is valid. Yeah.
That's gross. Points off would be that.
What happens if you send a message to nil?
Well, one more slide, I think, and I'll get to that. Okay, so nil is Objective-C's nothing object. So the kind of cool thing about nil is that if you send a message to nil, nothing will happen. In fact, it won't even crash. So, and the neat thing is that if the method that you're calling has a default return value, has some default value, so for number types, it will default, their default value is 0, for example. If a method returns an object, its default value is nil. Or if it's a void method, the method will actually just fail silently. So this is actually more useful than you think. For one thing, it eliminates the need for a lot of if checking. If I'm nil, then call this method. If I'm not nil, because if you are nil, nothing will happen. You can just ignore it, which is really handy. It can also be a source of bugs because something will fail and you don't know why, because something is accidentally nil. So that's something to watch out for. But it can be really useful if you're looping through a bunch of things and maybe one of them is nil and you don't want to check every time. Just having nil fail silently is kind of nice. There are some methods also that you provide methods that allow you to pass in additional information that maybe you don't need all the time, but sometimes you need it. These methods will allow you to pass in nil as a I don't really care, I don't need any extra data, I'm fine with what I passed in as the actual parameters, go to town. It's a bit like C's null, but it won't cause errors if you try to play with it.
The NSX, why was age 0?
The reason it's 0 is because if so presumably this function has a return type of like int or something. So if a method all types kind of have a default value. So like numbers, it's 0. Any object, it's going to be nil. I'm trying to think of any other examples. So anything that has a return, any value has some default value, and if the object you're calling is actually nil, Objective-C is smart enough to know what the type of what the return type of the method is, and it will just give you the default value, whatever it happens to be. Good question. Any other questions about nil? Okay, just a couple more slides and then we'll get out of here. Okay, so Objective-C defines its own Boolean type. In Objective-C, we say yes and no because we're talking to each other. So we don't just say true and false. We say yes, I have this thing, or no, I don't have this thing. It's a lot more. It's more declarative, I guess. It's kind of the idea. We're actually communicating, and we're saying we're responding to each other. It's equivalent to true and false and 0 and 1. It's pretty much. I think it's just type deft to be 0 and 1. So they're more or less interchangeable, but the Objective-C way to do things is to use yes and no.
That's clear.
And it's more obvious to somebody reading your code that you're using Objective-C Boolean types. Okay, and just one sort of last, before I let you go, a little style thing. Objective-C, as you've probably seen in all the stuff I've written, variables use camel case, which means that they start with a lowercase letter, and they're all lowercase except for where the word boundary, where a new word starts, to kind of indicate that there's a new word. So we don't use underscores like in C, we don't use dashes like in Scheme or anything like that. Obviously these are conventions, you can break them. People will have a hard time reading your code if you don't follow the conventions. The other one that's really common, and maybe some of you have wondered why all the base classes start with NS. The reason for this is that there's a convention in Objective-C that any classes that are logically grouped together should have a common prefix. NS, as you might guess, stands for next step. because that's where a lot of these core classes were developed. And then obviously Apple just decided to continue with the trend. So it's not uncommon to use your own initials for the prefix on a lot of your classes. I do that a lot. Okay, so that's all I have. Do we have any questions about the content today? Anything at all? Okay, cool. So I have account forms. I have 52 of them, which I think is enough. But just to be sure, can I first have all the people that are actually enrolled get one first, just to be fair, and then we'll make sure that everybody else can get one. While I'm gonna have Glenn do this so that I can get the lab turned on for you guys, and then from then on you have the rest of the remaining hour to work on the lab. Please wave your hands, ask us questions, find bugs in it for us, because there probably are some. Okay, and if somebody can hit the lights in the back for me, please.